Righty ho, let's jump into some maths. We're looking at area today. We're looking at area of 2D shapes and compound shapes. We're going to have to use our knowledge. We're going to have to work some stuff out. Let's have a look at this one. Question number 1. Look at the shapes drawn on the centimetre square grid. Important centimetre square grid, which means each square is 1 centimetre squared. For each one, work out the area that is shaded. Okay, so first one is, I think, given to us. 12 centimeters squared. This next one, we know that the area, if we think about our formula for that, which we've used before, area equals length times width. So for a square, it's simply the area is going to be the squared number. So the length is 3. 3 squared is 9. Okay, 3 times 3 is 9 centimeters squared. That helps us out because actually, if we look at this shape on the left-hand side, we have that same square inside it, okay, which means that if the square in the middle is 9 centimeters squared, it means that this odd shape on the outside here, which we wind up over here, which is actually an irregular quadrilateral, this shaded bit here, is whatever's left between 12 and 9, which means it's simply going to be 3 centimeters squared. You don't have to count it, you don't have to work anything out, you don't have to do any odd angles or areas of triangles or anything like that. It's simply the difference between 9 and 12 there to get you that answer of 3. Question number 2, what is the area of this shape? This shape is called a compound. CMP. Compound shape, if I can spell it correctly, there we go. This shape is called a compound shape. A compound shape means it is a shape which is made up of multiple shapes, okay? So it's at least 2 different shapes. So the way that you can do this is you either sort of split it off that way and work it out as this rectangle and then this rectangle up here. Failing that, you split it the other way and you work it out as a rectangle down here and then this rectangle here. Really doesn't matter which way around you do it. I'm going to leave it like this though, and then we're just going to have to use a little bit of reasoning here to work this through. Okay, so if we know that because this length here is 4 centimeters, that's going to be the same as down here, which is 10 centimeters, which means that whatever we have left over on the next side here is going to be the difference between 4 and 10. So I know that that side there is actually going to be 6 centimeters. Okay, which means I can work out the area of this rectangle in here. Okay, and to work out the area, I'm going to use my formula which I had from before. Area equals length times width. I might put that as a capital actually, so you see it's an L times width. And so then I just need to do 6 times 7, which is going to give me an area of 42 centimeters squared for this side. So if I highlight this side here is going to have an area of 42 excuse me, centimeters squared. And I can just pop that in like that. Remember that little arrow for the 2 means it's just a superset 2, so it's going to sit above it for the squared. Which then means I've just got my other side left, which is as straightforward as 4 multiplied by 10, so the other side is going to give me an area of 40 centimeters squared on this side, and then I just need to add those 2 together. 40 plus 42 is going to give me a combined area for my compound shape of 82 centimeters squared. And remember, it's centimeters squared as it says in the answer here, because it's centimeters times centimeters. Anything multiplied by itself is squared. Question number 3. The plan of a garden is made of triangles, rectangles and triangles. Sorry. The area of each rectangle is 12 square meters. Okay, so each rectangle, regardless of color, is 12 square meters. It's a pretty large garden. What is the area of the whole garden? Okay, well, let's just do a little count here then, shall we? We've got 1, 2, 3, 4, 5. Okay, but then I've got other bits on the side here. And if I draw, I wonder if can I draw a shape? Don't know if I can. maybe, so if I draw this shape here, rather terribly with my mouse-ish, so that gives me that shape here. What you'll notice is if I spin that round like that, because it's been cut corner to corner across the diagonals, that's just going to be the same area as one of the other rectangles, which means I can put this one here, this one with this one to make an extra rectangle, and I can put this one here with this one here, so two halves are going to make a whole. So I've got 4 halves, which are going to give me 2 extra rectangles in total, which is, I'll pop down there, which is going to give me 1, 2, 3, 4, 5, 6, 7 rectangles, which means I then have 7 rectangles, and if each one of those is 12 meters squared, that's going to give me a total area of 7 lots of 12, which is going to give me an answer of 84 meters squared. Okay. Question number 4. Nope, 3b is down here. The perimeter of the garden is 34 meters. What is the length of the longest side of each triangle? So the perimeter distance all the way around the outside. What is the length of the longest side of each triangle? Okay, so I've got a total perimeter. I don't know the length of the triangles, but that's fairly straightforward to work out. We're trying to work out this side here. Okay, so what I've got is I've got myself a 3 meter here, and that's going to, of course, be the same as 3 meters over here. So I'm going to have 3 plus 3, okay, which is going to give me 6 for those two left and right hand sides. If I look at the top and the bottom, I've got a 4 meter here, and that, of course, is going to be the same as the 4 meters at the top up there. So I've got 4 plus 4 of 8. Okay, so I had 6 plus 8, and that gives me 14 meters. Okay, I had 34 though. Okay, so I had 34 meters, and I've used 14 of them, and my 14 that I've already used has come from these sides here: the 3, the 4, the 3, and the 4. Okay, so there's my 14 already being used up there. That means I have 20 left. Now, of that, my lengths of my triangles are going to be the same. 1, 2, 3, 4. I've got 20 meters left, so I'm going to do 20 meters divided by 4. It's going to give me 5 meters for the length of each of those. And if I add those up, 5, 5, 5, 5 is 20, plus my 14 for my other side is going to get me to 34 back to my total. Question number 4. Here is a flag. What is the area of the flag? Well, we know that area equals length times width. Okay, so that means we need to do length times width, which means I need to do 125 multiplied by 60. Let me use my asterisk. Very good. 125 multiplied by 60. 125 multiplied by 60 is 7,500, 7,500. So that gives me 7,500 centimeters squared. I will actually make this one a bit smaller so it sits above it. Superscript that there. Lovely. So that's my area of my flag. 7,500 centimeters squared. 125 centimeters multiplied by 60 centimeters. I could, of course, convert that into meters, but then that wouldn't fit for my answer. So I just need to be careful and look at what my measurements are given in here and what my answer is asking me for here as well. It's just always worth a double check on that. Now, 20% of the flag is blue. What area of the flag is blue? So that is just asking me here to work out 20% of 7,500. Okay. Now, if I have 7,500, that is my 100%. So there's a couple of ways that you can do this. You can either know that 20% of anything is the whole divided by 5, because 100 divided by 5 is 20, so 100% divided by 5 is 20%. Okay, that's the quickest, most efficient way to do that. The other way to do that is to find 10%, which is to divide the whole by 10. 100% divided by 10 is 10%, and then multiply that by 2, because 10% times 2 is 20%. Okay, if I go for the first option though, 7,500 divided by 5, that's going to give me 20%, which means that 1,500 centimetres squared is the area of the blue part in the flag. Okay, 7,500 divided by 5 is 1,500. Okay, you should be able to sort of see that as well, sort of recognise that by doing 75 divided by 5. 75 divided by 5 is going to give you 15. 15 times 5 is 75. So you can see the relationship there in those numbers as well. Okay, question number 5. A rectangle has an area of 24 centimetres squared. How long could the sides of the rectangle be? Now remember, with these, make them as straightforward as possible. Okay, so the first option you're going to have is an area of 24 centimetres squared. You're going to go for 1 and 24 because length times width. 1 times 24 is 24. Okay, now instead of trying to work out anything else in this, I would then go, okay, well, what happens if I make the side 2? So it was 1 before, let's make it 2 now. What times 2 is 24? Well, that's going to be 12. 2 times 12 is 24. Length times width is the area. So 2 times 12 gives me an area of 24 centimetres squared. Okay, now this is essentially becomes a game of find the factors of 24. Okay, next one to do on that, I would suggest go, okay, well, if 1 worked and 2 worked, let's see if 3 worked. Can I multiply anything by 3 to get 24? Yeah, 8. 3 times 8 is 24. Now, there are many more ways you can do this. It doesn't say you have to have a whole number, so you can do it in much more complex ways. My advice for these is always do the most straightforward, the most simple first. Okay. Question number 6. Rectangles and squares. Here is a rectangle, 2 centimetres, 8 centimetres. I'm not looking at the question at the moment, but I know that from my area equals length times width, I know that the area of that is going to be 16 centimetres squared, like that. Okay. That might help me, not sure. Square has the same area as this rectangle. That is going to help me. What is the side length of the square? Okay, we know for squares that all the sides have to be the same length. We know that for a square it has 4 sides, which means that to find the length of this, of each side, for my length times width, I'm going to have to do, what I'm going to have to do, I'm going to have to find a number that if I multiply it by itself it equals 16. So I'm looking for a square number, or a number rather, that when I square it I get the answer of 16. When you start thinking like that, you'll realise that 4 multiplied by 4 is going to give you 16. And if you think of your square numbers, it's a square, so think of square numbers. 4, 4, 4, 4. Okay, so that's going to give me the perimeter. Don't need it for this part of the question, but 4 multiplied by 4 is going to give me an area of 16 centimetres squared. Okay. A different square has the same perimeter as this rectangle. What is the side length of this square? Okay, so the perimeter here, perimeter equals, we should remember, perimeter equals 2 times length plus width. Okay, so 2 lots of the length plus the width. So then if I go up to my rectangle here, I've got 8 and 2. So that's telling me that to find my perimeter, perimeter equals 2 times 2 plus 8. And if I use my BIDMAS knowledge there, it means I know I need to do my brackets first. So I'm going to have perimeter equals 2 times 10, because I do 2 plus 8 first because it's in the brackets, which means that my perimeter equals 20. Okay, so I have my perimeter. Now, a different square has the same perimeter as this rectangle. Now, if we go back to our first square here, if I had 4, 4, 4, 4, it would give me an area of 16 centimetres squared, but also a perimeter of 16 centimetres. So that can't be the same. It can't be the side length here. Now, I know for a square I have 4 sides. I know that all 4 sides are the same length. which means if I want to find the length of one side, knowing the perimeter of the square, and I do know the perimeter of the square because it has the same perimeter as the rectangle, I can simply take that number there of 20 and divide it by 4, which is going to give me a perimeter of this square of 5. Okay, question number 7. I have a square piece of paper. The diagram shows information about the square labelled A. Okay, so 8 centimetres. Okay, so area for this one here is going to be 8 times 8, which is going to be 64 centimetres squared. Perimeter here is going to be 8 times 4, which is going to be, so my perimeter is 8 times 4. My perimeter here is 32 centimetres. Okay, that might help me, it might not. I fold square A in half to make rectangle B. Okay, well then let's label this up. I know that one of my sides is going to stay the same. That's going to be the length across the top as 8. The other one has been folded in half here. It says in half, which means that the length of my sides is going to be half. So it's going to be 4 centimetres. Okay, that's fine there. Let's work out what the area is. The area here is going to be 4 times 8, which is going to be 32 centimetres squared. And the perimeter here is going to be, let's go back to our formula before of perimeter equals 2 times length times width. Let me move that so it's not on top of the writing. Length plus width, sorry. Okay, so 8 plus 4 is 12, multiplied by 2 is 24. So that's going to give me a perimeter of 24 centimetres here. Again, I haven't looked at the answer for the question for this one yet. I'm just writing down what I know from this already. And you can see here my little annotations of what these lengths are going to be now might prove to be really helpful. It might not, I don't know, I haven't looked at the question. I then fold rectangle B in half to make square C. Okay, so square, so all the sides are the same length. That's good to know. B's been folded in half, which means I'm going to half that. Actually, I can see from that, that means that all of my sides are going to be 4 centimetres. Okay, which means that my area is going to be 16 centimetres squared, and also, interestingly for this one, my perimeter is going to be 16 centimetres. Because I have area 4 times 4, 16, perimeter 4, add 4, add 4, add 4, 16. Complete the table below to show the area and perimeter of each shape. Okay, there we go, already done. So I can just take all this information I've already annotated on the question, I can just drop that straight into there. I'll start again with square A, 8 times 8. Sorry, 8, 8. Let's look at the next part of the question. Then fold it in half to make triangle D. What is the area of triangle D? Okay, well we know that the area of a triangle is half of base times height, which we also know actually base times height is kind of length times width of the rectangle, and we also know that a rectangle is a particular type of square. So the length times width was 8 and 8, so that was 64. So the area is half of 64. You can see we've taken the whole area of the square, we've chopped it in half, so the area is simply going to be half of that. So the area is going to be 32 centimetres squared. One of the statements is true below is true for the perimeter of triangle D. Tick the correct one. The perimeter is less than 24 centimetres. The perimeter is 24 centimetres. The perimeter is greater than 24 centimetres. Okay, so here I know that I'm going to have 8 and 8. That's going to give me 16. Okay, and then we're going to have to kind of work out what our other length along here is going to be. And if we're thinking about that, so you know, if it was an equilateral triangle, it would give me all 3 sides the same length, which would mean it would be 8 and 8 and 8. And it's not an equilateral triangle, it's a right angle triangle. What you can also tell from this is that this side here, the one that we don't know, is the longest side. I know that the one at the bottom is 8, I know that the one on the side is 8, but I don't know the one where the arrow is pointing towards it. If it was an equilateral triangle, the third side of my triangle would be 8 centimeters. It's not an equilateral triangle. The missing one is going to be greater than that. If it was an equilateral triangle, the perimeter would be 8 and 8 and 8. It would be 24. This is greater than these two. You can see that, and we know that because of the properties of a right angle triangle. Okay, so that means here that the perimeter can't be 24, it can't be less than 24, so the perimeter must be greater than 24. Okay, we know that through logic, we know that through our knowledge of isosceles triangles, right angle triangles, and also equilateral triangles. Okay, so that would go into your explanation for that. Question 8, tick any areas below that have tick any rectangles below that have an area of 12 centimeters squared. Area is length times width, so this should be fairly straightforward. 3 times 4 is 12 centimeters squared. Yep. 2 times 4 is 8 centimeters squared. No. 2 times 6 is 12 centimeters squared. Yep. 3 times 4 is 12 centimeters squared. Yep. So there's 3 of those to be ticked. Okay. A square has an area of 100 centimeters squared. What is its perimeter? Show your working. Okay. So knowledge: square, all sides the same length. Okay, area is 100, which means I need to be looking for a square number that gives me the answer of 100. So if I square a number, it will give me an answer of 100. If I know my square numbers, I know that 10 times 10 is 100, which must mean that each of these sides here must be 10 centimeters long. Because it's a square, I know that I can just work that through there, and then the perimeter is all the way around, so it's going to be 10, 10, 10 and 10, which is going to give me a perimeter of 40 centimeters all the way around that square there. Okie doke, hope this helps.